and welcome to today's mission, that is Gitofy. And today we will be talking about four things here. One is with respect to Git-based workflows. So how do we work with the remotes? How do we fork and clone the repositories and start working with multiple remotes? So I'm going to give you an example of that. Then we will talk about branching, merging, and pull request-based workflows. That's going to be the foundation for the next thing when we start setting up the branching models or the real Git-based workflows that drives your development workflows in your organization. And one specific thing that we're going to implement here is called as a trunk-based development model. And then we will also learn about very briefly about how to tag your releases when you are actually releasing your products. How do we go about tagging the releases, etc. That is something I'm going to explain to you as well. Before we get started with Gitification as a mission, I have a question for you. Who created Git as a software? If you know, you can put it in the chat. Who was the one who created Git as a software? Now, if you have no clue, I'll give you one. Do you know who created Linux? Linux as a kernel, and then came the operating system components with the GNU project. So that's why it used to be called as a GNU Linux at some point of time. And the creator of the Linux is the creator of Git. That's the clue. And it's the Linus Torvalds. That's right. So if you don't know, just search for it, right? So if you want to say who created Git, ask Google, you're going to get the name. Is the Linus Torvalds who created Linux as a kernel. Who's the one who created Git? I think he wrote it in like 2 to 3 weeks. That is back in 2005. Interesting fact there, right? Second question for you, is Git a distributed revision control system or is it a centralized one? Is it centralized? Is it distributed? There's a question from Shruti about the previous missions. You can not attend the live one right now, but you will have a recording. So you can get the recordings and access to it. You can also go to our YouTube channel, that is School of DevOps, and find the recordings right there. So Linus Torvalds is a good right answer. Suraj, Saddam, Cedric. Oh, this is a very aware audience. Udit, Olavle. And distributed it is. So it is a distributed revision control system. Why it is called as a distributed as well is because every single copy of Git, when you clone it, is a complete copy of your repository. That is a complete copy of your repository. It's not a centralized one. Even though we kind of imitate the centralized model in a way because we have GitHub and so on. But by design, Git is a distributed revision control system. That's what it is. Okay, I'm just going to connect my iPad and we should be getting started in a few seconds once it is done. Okay, so here are the 4 topics that we're going to explore today with Gitofy. One is about, we'll get started with the concept of remotes, forking, cloning, then talk about the remaining topics from there on. So on the topic of forking, cloning, and remotes, basically, let's say every single repository is a copy of your actual original repository. Let's say you have a repository on GitHub and you clone it locally. That is your own local copy that has everything in the master repository or the one you've cloned it from, and you can talk to any other repository on either remote as well. You can also have multiple remotes that you can work with. For example, a typical open source development works this way. There is a Upstream repository. Let's say I created an open source project. That's me, my repository on GitHub. Let's call it as Upstream. And now you want to contribute to it. You want to try it out. You want to contribute to it. You want to modify that code because it's available under open source license. So what you do is you create a fork of it. When you create your own fork, this is the Upstream. This is your own fork. And typically that's the one you would work with because your fork is the one where you can commit to, and that's where you can clone from. So you can clone, you can commit, you can push the changes to your own fork. And when you are ready, when you want to bring those changes or submit those changes to the upstream, because let's say you've added a new feature which might be useful for many others. And that's how the open source development works, right? So there is an open source project, I cloned it, I added a feature, maybe I fixed a bug, and I want to contribute it back. So how do you contribute back to the upstream? One is either you can add this as a remote if you have access to it, that is, right? If you don't have access to it, what do? If you don't have access to it, you can't, of course, add it as a remote. So what you do is you submit the changes here, and from there you raise something called as a pull request. So that workflow is something I'm going to help you get familiarized with. So starting with, I'm going to create a fork of one repository that I have already, right? And then I'll try to imitate the same workflow here. So this is an upstream repository. Let's call it as upstream. And what is my upstream repository? That's the one I'm going to begin with. This is my upstream that's called as Craftista. That's the same use case that we are working on. And let's say if I'm a user like you are, and if I don't have access to this, I cannot submit changes to this particular repository because I don't own it. I mean, right now I do, but let's hypothetically, you are, I'm you, and you don't own it, so you cannot submit the changes to this one directly, right? So what do? You will have to fork it. So what you do is, and this is available under an open source license. You can also check with the licensing terms and all that. This is, in our case, it's a partial license too. So you're free to fork it, make changes to it, create your own features on top of it. So that's a open source license already. So what you do is you create a fork of it. Let's assume that I'm again into the hypothetical situation, and what I would do is I'll create my own copy of it, or fork of it as we can call it. So I'll pick one of my accounts or organizations, and that's where I would create a copy of it. While creating the copy, I can also decide whether I want to copy the entire repository with all the branches, because sometimes there are like tens of branches available. I may not be concerned about it either, or I can skip that branching. So when you see this, the default option is skipping everything except for the main branch. Currently, the trunk is the main branch. Earlier it used to be named as master. Now it is main. So I'm creating a fork of it. When I create a fork of it, I get a copy, the exact replica of that main branch at this point in time. And from here on, unless I bring the changes in, it is divergent from the upstream. So what I've just done is create a fork of it, which is my own copy of it. So this is my own fork. Now this, when I clone, becomes my origin. That's called as a remote. So on my workstation, I'm going to clone it. Let me do that. So this is my workstation. I'm going to copy over the repository. And you can see here, this is DevOps -0001 Craftista. That's my own organization. And this has been forked from Craftista/Craftista. That is the upstream for me. So when I clone this repository using git clone, I get a copy of my own fork. How do I know which is my origin, which one I've cloned from? Sometimes you need to find out these kind of things. So you use git remote show origin, because it was added as the origin for me, and I can see that it was forked or fetched from this particular account on GitHub. That's where it comes from. That is my origin right now. That's one of the remotes. It doesn't mean that I cannot work with my upstream or anywhere else. I can still do that. And I can add that repository as upstream as well. So for example, this is the upstream, the original one, and I can add that as a remote so that I can talk to this or that as well. So right now, when I clone, I'm working with only one remote. That's the only one which has been configured with me. I can connect it to this as well. If I have the authorization to talk to this, I can add it and connect to that as well. And maybe clone, at least I can pull the code, because A lot of times what happens is we create a fork and we don't know how to update our own fork. Once you have cloned it, this connection is not like from Git, there is no direct connection here, right? So this connection is kind of gone. So sometimes we don't know how to update this fork. A very easy way to do that is by cloning, bringing the changes in, and then pushing it here. It's as simple as that. How would I do that is I will bring the upstream, add it. So git remote add. You can call it anything. I'm just adding this as a reference or a name or alias, called as upstream. Upstream is this original repository, and this is where it gets added. Git remote add upstream. And I can verify that by looking at git remote show, and I can see there are two remotes now, and I can see the upstream here. See, that's where it is. And when I bring the changes in, I can, generally we have the tendency of using this, right? This is the habit, right? Git pull origin main. Similarly, you can also use git, this is just a remote, a reference to the remote git pull upstream main. You can make changes. Let's say I made a change to this. I'm gonna try this. I have a control over upstream, so I'll just add a file or make a change directly to this. Creating a file, a new file. It's not as part of my fork, okay? It is added to the upstream, but this is my fork. It doesn't get updated automatically, right? So one way, there are other ways to do this as well, but one way is to bring the changes from upstream into my workstation and pushing it to this repository. So I will show you that. So git pull upstream main, you see the change added, you know, it's gone to my commit. Yeah, it's part of upstream. So you see it's there in upstream, not in the origin yet. Origin is one commit behind. So git log is a very useful command to understand what's going on, what is the current status of which remote, which branch, local, and so on. And if I want to push it to my origin, all I have to do is git push. You will see the change here, by the way, this new file, and I can say git push origin main, and it will help me publish the change to that. Here I need some password. I have generated a token instead of a password, which is a more secure way of doing it, and I'll invalidate that in some time. Yeah, so now that I have published the changes, these changes, this is my fork, and my fork has that change now in the test.txt here. That's how you work with the remotes. That's how you fork. That's how you make changes, and you commit the changes, make publish it to different remotes as well. That's the way you can do it. All right, what are we learning today, Mohit, is forking, cloning remotes is what we are at. We'll also talk about branching, merging, pull request-based workflows, set up the implement trunk-based development model, and learn about tagging releases. So just essentials of Git, pretty much. And we will set up that trunk-based development model for our project, which is Craftista. That's the objective for this week. So very simple, very easy. It's a very lightweight topic for this week. All right. Now, the next thing that I want to talk about is just 3 trees of Git. When you work with revision control in general, one of the interesting things about Git is there are 3 different trees that it comes with and 3 different places that where changes happen. Can any one of you know or name those trees? So if you know the 3 trees of Git, put it in the chat, please. We seem to be an aware audience. So what are the trees of Git that you know about? All right. So there are 3 things or 3 trees of Git. One is called as a working tree or work directory. Okay, that's where you're working. That's where you have cloned. In my case, work directory is wherever I've cloned, and whatever changes I'm making, initially it is just in the work directory or working tree. It's not been committed. It's not added to the commit. There is something else in between as well. So no, master main are branches. These are not the trees of Git. When you do the development with Git, it's very important to understand this concept. Very basic concept related to Git, but at the same time, very important. So there's a working area, working tree. Stash is more like you stash the changes and they're hidden from the commit history and so on. But there's working tree that is called as a index or a staging area. I call it as a staging area. You can also call it as an index. And then there is a commit, or you can call it as a head. You can call it as a commit. More like a head. Let's call it as a head. All right. Head is like wherever your it's a tip of the tree, wherever it is pointing. It's a pointer basically, and that's where the commit history is. So this is where your commit history resides. Is right here. So what do you mean by these three trees, and how do you identify them? How do you explore them? How do you work with them? Right. Let's explore that a little bit by taking an example. I have forked the repository. I have cloned it. So Udit, it's correct. Working, staging, and Git repository, or a commit tree, or a head, you can call it. So what are we talking about? Right now, everything is in sync. I have no changes apart from what I have checked out. So what you do is you check out the code from the repository, or from your head, or from your commit history, right? So from there you check out. That's what you begin with. After checking out, you make changes to some files, maybe add some files here. Yeah. So let's say there's a test.txt that I update from local. I add xyz dot YML in addition to that. So currently, let's understand step by step. Git log shows me everything is in the same place. The head is pointing to the main branch. That's the tip of my main branch, right? That's my head. This is my commit history. I have all the changes in here. And even the upstream origin, everything, the head from the origin is also pointing to the same commit. So everything is in sync right now. And if I look at Git status, no changes. Working tree is clean because I have not started making any changes locally at all yet. Now I will start doing that. So first thing that I do is test.txt, and I say change one, ch01. Okay, so I've made some changes. It should reflect somewhere. Where that is the working tree first, because I'm not staging it for the commit. I have not committed it, so it's not there in the Git log at all. It's not there in the staging area. I would have seen it in the staging area if I use Git status. Git status, does it show you that it is staged something? Nothing here. Changes not staged for commit are the files that are modified. So it's all in the working tree right now. So whatever changes I'm making are still right here, just here, nothing else. And how do I add it to the index is the command that we did mention, git add. But I'll make two changes and then I'll tell you why staging area is important. So I'm creating a file, xyz.yaml. Let's assume that some sort of a code. I'm just adding some code, okay? This is a Kubernetes pod manifest. I want to now git status shows me there are two files. One was already present, that has just been modified. There's an untracked file, it tells me about that as well. Now I can selectively, I may have modified 10 files, but not everything do I want to commit. I just want to commit maybe one file or one change, that is this change maybe. So I will just say git add, and I can selectively add a file to what, to the staging area. So what I did here is I just took one change and I said, oh, add it to staging area. With git add, what happened? It went from here to here now. Not this change. This file is there, but not the change. I'm talking about the modification. That's not gone here. Only thing that went from here to here is this. So what do I see now? Git status. Changes to be committed. That's my index or the staging area. And this has not been staged. So this is my local change. It's not been staged, only thing which is changed. So if I commit, it will only take this change. Why this is helpful is you may modify 10 files, but you want to commit in batches, like, oh, this is a feature related to this feature, there are these many files. So you only commit those many files. So you can do that selectively if you know about these things, basically. That's why it is important to know the 3 trees of Git. So if I do git commit, just say git commit, I have to configure Git here. There are different configurations with Git. I will be using global. What are the other configurations of Git that you know about? Are the scopes we are talking about? We're talking about global scope here. What are the other scopes that you know of? Just gonna go ahead and configure it for now. In the meanwhile, if you know the scopes, please mention in the chat. Just like global, what all can you configure? And what do you mean by global? Right? So if I use git config list, I have a lot of configuration here. And out of that, this is the one I just added. That is my global configuration. And this is related to the repository, the remotes and stuff. So I see all that config here. Now, the global configuration is for my user. You can see there are 4 different configs. Probably you will see it. There's global. There's a system config. This is system wide for all the users. This is for me, my user. There is a repository specific. So even for you, your own user, if you have different configuration for different repositories, you can do that. You can also do it per work tree. So you can go even granular and configure it that way. So what we have configured is for the user. That's typically the case you would use. So I have added that configuration. Now, why did I added this configuration was I wanted to commit this change. Whatever has been staged, only that much. So git commit opens up an editor and I say, oh, added a file, spec. And now what happened? It went away from this because it was moved away from here. It went from the staging. Staging area is just a staging area. It's like a temporary thing. It holds the changes until they are committed. You can also remove the things from the staging area. That's the beauty about staging area. So it's like a temporary buffer. It holds things till it is committed, or you can edit that, and that gives you a lot of flexibility. So Git is a very thought about revision control system, you may say, right? So it's gone into the commit history now. So when it goes to the commit history or ahead, what that means is now git log should reflect it. And it's interesting because all my remotes are still at one commit earlier, but my head, the current head of this repository and the branch is now moved ahead. And when I say git push origin, it syncs it with the origin or wherever. So origin is at what commit? You can see that origin is at commit number 833b6. So this is, I'll exclusively working with this, my own fork. So you can see that it's at the 76th commit. Commit ID is 833b6. This one, this is where it is at. If I want to sync it, that's when I say git push, or what I'll do is I will show you git status. This has not been staged, right? I will add it. So git commit -am. I can do that. Yeah, -a will take all the changes and commit it anyways, right? So it stages and commits it, and it does both. So I'm saying ch01. Now it's gone from the staging area, it's gone into my commit history. So I have a change now. So my local head, the branch, has moved 2 commits ahead. And if I want to sync it with the origin, this is when I would say git push origin main. And the changes are reflected here. It was at 76th commit. Now it should be 78. Yeah, you can see the change. You can see the commit ID 8519. 8519 it should be when you look at git log. That's how it works. Yeah, so this 3 trees of Git, how do you start working with it, is an important concept that you must know about. We talked about this. We talked about forking, cloning, remotes. Let's talk about branching and merging next. Branching merging is going to set the foundation for the collaborative workflows as well. So what do you mean by that is, typically when you're working on in a collaborative environment, you have many developers working on the same code repository. You typically have one main line of the code, and then whenever you're working on different features, you typically sort of branch it off, right? You create a branch, a new development branch. So let's say this is your trunk or a main line of the code, and you create different branches like a feature X. Maybe simultaneously there are different developers working on this. So all the commits that you make now go here. There is a feature Y. Maybe there is at this time we created a bug fix branch, or whatever you want to call it. So you can create different branches, and then the commits go in here, and then you bring the changes. When you bring the changes in, you merge them. Let's say you merged it here, and this branch wants to merge here. Maybe this should first bring the changes, merge in this way, and then make a pull, merge in here. So when you decide to merge, you bring the changes in using something called as a pull request. It's a very simple concept. Pull request actually is a request to merge. That's what it is. It's actually a merge request. It is called as a pull request. So you're asking someone to pull your changes into there. So it's a request to merge actually. So how does this workflow happen? So let's understand this. So git branch, git checkout -b actually creates a branch and also checks out the changes or downloads the changes. Otherwise, you can do it in 2 steps as well. I'm just doing it in 1 step, where I would say git branch -b, and then I'll just create a branch called as feature X. Yeah. Now my feature X branch is what I've switched to, because this has created the branch and switched to it. And git log shows me that the head, because my current commit tree and the head for that, the pointer is pointing to that feature X branch. The tip of that branch is where it is. My upstream, you will notice, is still at this level because I've not pushed the changes to the upstream, only to the origin. So this is where the head is. Everything is pointing to the same location right now in the commit history. And this is where I can start making changes to it, because let's say I'm working on a new feature. So I add something. Right. And then I start adding the code, right? So typical code for a Kubernetes service, maybe. It's gonna take the code from, oh, that's ours, or not. Yeah. So let's say I added a feature, which I can check here. It's a new code. So I add it to the commit history. If I say git add all star, it's gonna take all the changes that I've made and add it. So you already probably know about it. What that means is now it has gone to the staging area. So changes to be committed the staging area. And then this is my branch, not my main. So when I say git, if I want to commit that, I did, and it goes into my branch. Okay, the branch is what gets updated. That's where my head is pointing to. My origin doesn't have this branch yet, and the main branch and everything else is just one commit behind, because I've started working on a branch which is exclusively available only in the branch. The reason why you want to create a branch is so that whatever is in the main line is not affected because of whatever experiment that you are running while adding that feature, adding the bug fix, and then you can bring the changes in by merging through the pull requests. That's where the pull requests come in. So if I want to commit this, I'll say git push origin and feature X. At this time, the branch will get created automatically. Right now it doesn't exist. Can show you that. Refreshed it. It's only main branch. And only when I push the changes will it get reflected on my repository here. All right. Now you see there's a new change here. Now the commit history here at 78, if I go to the branch, that's when you don't see that service.yaml here. If you switch to that branch, would you see that service.yaml? So 79 commits. You can also look at the commit history and see what happened in that commit. You're gonna see a new file added here, and that's the diff that you see here. How do I bring these changes? Let's say this feature X is where I have commits. I want to bring these changes into the main line. To do that, to make this happen, I have to raise something called as a pull request, right? And pull request can also be raised. And that's when I said that one way of bringing the changes into the upstream from here to here is through the local workstation. I showed you that by adding a remote. The other way could be you can create a pull request this way if you can, or if you want, you can do that as well. Or you can, let's say you've added a change here and you want to push it to upstream, or you want to have the upstream repository, the original repository, bring the changes, your changes to be added here. You typically raise a pull request. That's how the collaborative open source workflow happens in the open source world. Actually, somebody creates their upstream repository, you fork it, you make the changes, you test it, you add your features or bug fixes, and then you raise a pull request saying that, hey, these are the changes I've made, you may want to incorporate those. And if they want, they can pull the changes in through that merge. Basically, that's when this pull request based model works. So I am going to bring the changes in from the feature branch to the main branch of the same repository right now. So I say compare and pull request. You can also go to the pull request tab here and do that. And when you raise a pull request, one thing that you would notice is it's actually doing this, because it's more like designed for this open source collaborative workflow where you don't have access to upstream, but you fork it, you make changes, and then you raise a pull request so that from here the changes can be incorporated or pulled or merged into here. And that's the reason why it shows the upstream first. Craftista /Craftista is my upstream and my own branch and a repository. If I want to bring changes from one branch to another, here I'll have to change it to my user ID, same user ID, and then it shows only the branches between this and this branch, and you add the description of the changes here, right? Create a pull request, and here you can set the policies. That's where we're going to start talking about implementing the branching models, etc. Right now there are no policies, nothing blocking here, so it goes and allows me to merge the changes into the master main branch that is here, and I can examine this pull request from here. So if I'm an admin, I can or if I have an authorization, I can go and look at the pull request and then decide to merge it. When I look at the pull request, I can look at the changes as well, like what are the commits, which files changed, what are the actual changes, and then I can, there's a review process that you can set up as well. And in this case, I'm just gonna simply merge the changes in here right now. That's the pull request based workflow. This is the foundation for the setting up the collaborative workflow and implementing the branching models. Any questions so far? All right. If no more questions, let's talk about the branching models. What are the branching models that you have heard of, aware of, used? Anyone? That's a question to you. Branching models are important because that drives the development workflow, which is going to drive how fast you can develop, how efficiently you are doing it, how complex you are making it, right? Because that's when a lot of things can go wrong and lots of conflicts can come in. You may spend a lot of time doing that, and so on. Hotfix is a way you can create a branch and merge it and so on. Part of it maybe, but you have to create the branching models, right? So, and that drives your development workflows, and that also drives how safely you are bringing the changes into the main line. So, all right. So branching models, I've not gotten any relevant answer here so far. So there are few branching models out there. I'm going to talk about when you look up, search for Git branching model, right? You would have definitely come across this diagram. This is one of the most popular articles related to these branching models by nv.com. This was published in 2010. It's quite popular. And in fact, my previous organization that I worked for, we had a similar model. Some names are different, but it was a very similar model. And that was back in 2005, 7, up to 2012. I was there, and we used to use we earlier had a CVS revision control system, and then we moved to SVN. And then from SVN, later on, I hear that they moved to the Git-based workflows because, Git is much more efficient, simpler, avoids a lot of issues with merging and merge conflicts and stuff. And it's definitely a better option today. So this branching model is called as a GitFlow. Yeah, this came to be known as GitFlow, right? Now, what is this? What are we talking about? How our development works, right? So let's say we keep one main branch. Why are we doing this? To safeguard the changes and to allow collaborative development and allow different features to be developed simultaneously, to allow different people to try out new things, experiment with it without affecting the stability of your mainline code. Let's say I'm running an experiment, I break my things, it is in that branch, right? It's safeguarded that way. And then before breaking changes and bringing the changes in, you can further do the checks, and that's when we implement the branching models and policies there. So essentially what we want to do is whatever the main line or a trunk as we call it, that's where all the changes ultimately go to. That's our main line, that's our trunk, that could be a different branch called as develop. This depends on different branching models, right? In case of this particular branching model that you see, the trunk in this case is the which branch is a trunk here? The main line, which appears like a main line here. You can mention the color if you want. The main line here is the trunk here is the look at this. Develop, that's correct. Develop is the trunk here, and everything, you can see everything being forked out of here, everything coming back to the trunk. So there is a develop branch, and then there are feature branches. Every team, everyone who wants to work on a particular feature, they can fork off it or branch off it rather, the develop, and then that's where they work on their features. And at a regular interval, they bring the changes into the main line. So one of the things that you want to ensure is the build never breaks on the main line. How do we ensure that? Whatever code goes into the main line, we also want to make sure that it is stable enough, because this is where everybody's fetching the changes from. And if that is broken, that can have repercussions. I have seen this personally. So if the build breaks in the main line, the work stops for everyone. And that has happened many times that I've seen that, we had 150 developers, different teams, different, working on the same code base. And if the build breaks, everybody's work stops because, I'm trying to test some changes. I cannot because the build breaks, right? So that should never happen. How do we safeguard that? That's where we implement certain branching models and certain policies there, right? And that's what we are talking about now. So we have feature branches, and whatever changes you're making, it happens here. And then you ensure that you test it before you merge. That's where you can enforce the policies. And then you have other branches, like release branches. Typically, let's say you have you do releases every fortnight. Every 15 days, you're doing release. So at the beginning, you have a sprint leading to the release. So at the beginning of the sprint, you create a release branch. So whatever changes are going to go in the next release are being committed or being brought into that particular branch from the develop here. So let's say you created a feature branch, it went to the main, and from there it went to the release at that point of time, right? And that's what is happening. So you keep that branch for that release, and then at the end of that sprint, you make the changes or bring those changes or merge those changes into the master branch in this case. In this case, it's kind of whatever goes into the master seems to be being released to the customers, to the outside world, to the production environment, right? So this, in a way, that is more like a production branch. If you find an issue on a production, what do? That's when you create a hotfix branch. That's when you see a hotfix branch, and that you see that it's forked out of or branched out of master, because this happened after the production. It went in the production, and then whatever changes you're making, of course, you'll bring it or push it to your production branch or a master branch. You also bring the changes into the develop so that that change is incorporated for the next release and so on, because this is like a hot fix on the production. That's how you go about working with the GitFlow. Now this is a bit complex, and the more complex you make, it gets you get into the issues of conflicts and merge conflicts and those kind of issues and complexity and so on. And that is where you have a simpler option for it called as a trunk-based development model. And it's absolute simplicity, a trunk-based development model. If you just have a handful of developers, what you're doing with trunk-based development model, in that case is everyone is bringing changes into the trunk directly. And from there, you push the changes. Let's say whatever needs to go to a release, you raise a pull request, and then you send it to the release branch. That is the simplistic model. A more realistic model and a common one is more like you have different branches. These branches are also short-lived, like 1 day, 2 day, and you work on small parts of the feature, and you often incorporate or merge the changes into the main line. And when those changes are merged into the main line, you incorporate certain practices there, the best practices, so that whatever goes into the main line, the build should never break. That's the criteria you must set. All the unit tests should pass, because we also talk about with DevOps shifting left in terms of testing. So as many issues as you can find, as early as possible. It is cheaper to fix, it is quicker to fix. If the issues go to the production, it is difficult to change, it is expensive to change. So that's why the shift left philosophy. And in order to do that, what do is, let's say you created these branches. For every feature, you create a branch, right? You branch off it, you make the changes, add your features. These typically are short-lived, so every day, every 2 days, you want to bring the changes in. Now, these changes need to be brought in safely. How do we ensure that safety? First of all, how do we bring the changes in? Changes are brought in by raising a what? A pull request. You may have guessed it right already. So the changes have to be brought in via pull request. First thing first, to implement this trunk-based, if I have to implement a trunk-based development model, what would I do? I will start doing this basically. I will lock down the master branch. Nobody is allowed to check into the master branch. That's my first policy. The only way to bring the changes in is via the pull request. That's the first policy that I will implement, right? So lock down the branch, protect it. The only way to bring the changes is via pull request. And when you raise the pull request, you want to incorporate certain practices, and the pull requests are also blocked until you qualify the criteria. What criteria? Criteria number 1 is you must pass the CI pipeline. That's where you have the checks, right? The continuous integration pipeline. That is what we're going to build next week. That's where we have jobs like build, test, maybe package job. At least the build and test should pass, right? Because that's where we make sure that the build never breaks. That's where we make sure the unit tests are passed. And these checks or this pipeline can be incorporated into pull request, and the pull request will only allow you to merge when the CI pipeline says okay, right? When you get a green thumb from the CI pipeline, you also want to incorporate a second aspect of it, that is the code reviews. Code reviews are your peer reviews. An ideal number of your peers who should look at your code is number 2, right? At least 2 of your peers typically. So it's basically the extra set of pair of eyes to look at your code. So if you have missed something, if you have forgotten something, if you have overlooked something, somebody is there to at least detect those issues, right? That's the best practice. So code reviews is where we basically incorporate that second practice. And this can be done with the pull request, and this can be done with the GitHub configuration, and that's what I'm going to show you. So how do we incorporate this, where we lock down this branch, we only allow changes via pull request, and when the pull request come in, we only allow the changes to go in after the continuous integration says okay and code review happened, right? So it's a very simple change. Right now, anyone is allowed to bring changes to the main branch, main line. I have shown you this, right? I've committed to the feature branch, I've committed to the main branch. So I've already shown you that. Let me just delete my feature branch here. Right, and I can delete it from the repository as well. So I've deleted locally. I'm going to delete it from here as well. So after this is done, in fact, I had an option to do that here, right here, to delete this branch, and that's gone. So the code is gone into the main line, where you can see this commit history, the changes are here, and that branch is gone now, right? So you will find it in the history because there's a merge from this branch, this is what happened, and all of that is there, but the branch has been deleted because you don't keep the branches which you don't need all the time. We keep cleaning those. That's a good practice. Now let me create a change. And I see it here. I can commit by adding it. I can publish the changes. I have to pull the changes first because I've merged something into my main line. So I need to first pull those changes. Yeah, and then push it back. Did some merge and stuff, and I'm just gonna push it back. So right now, all of this is allowed basically. Yeah, I'm committing directly to the main line. What I want to do is lock down the main branch, only allow changes via the pull request through the branches, that means, and then we want to incorporate these policies. At least I can show you the code reviews next time when we have a CI pipeline, we can integrate with this as well. So right now I have just the main branch. I'm going to lock it down and add these policies. Setting up these policies is very simple. All I have to do is go to settings. This is the repository. I'm an admin, so I can change the settings, and from here I go to the branches, and I would add a branch protection rule. That's what it is. That's where all the configuration resides. It's very simple configuration. Just add the branch name or a pattern. In this case, just a main branch. Can be a pattern as well. Regular expressions work here. And the moment I add this, my first policy is set to lock down the main branch. It's kind of done here. Next thing I would say, require pull request before merging. So now I'm enforcing the pull request. Along with that, I can enforce the reviews. So require approvals is the number of reviews. A good number, ideal number is 2. Now, since I don't have a lot of reviewers and reviewer accounts, I'm gonna stick to 1. I have created a secondary account, a GitHub account, that I would be using as a reviewer account. I'll show you that. So this is my reviewer account. Okay, this is the reviewer account, and this is my primary account, the one I'm working with here. This is the primary one. Now I say require approvals, so it is going to allow me to merge only if it has been reviewed by at least one person. And then I can add some policies here related to that, pull request, tail request, and all that. I'm not going to get into that right now. The second thing that I can add is status checks to pass. Now status checks, as in if there is a status checks API that GitHub has, if I have Jenkins, which is integrated with Git, I'm going to show you how to do that in the next mission. Next mission is about pipeline it. That's when we create the CI pipeline. That's when we integrate with Jenkins. That's when we're going to talk about how this two-way integration will work with Jenkins and Git. And at that time, we can add this check as well. So right now I don't have the status check, so I can't add it. I'll stick to just the review process. And then one important configuration is I have to say, do not allow bypassing the bow settings. Otherwise, what happens is, if I'm an admin, it allows me to bypass. We don't want that to happen, right? Simple, but important configuration here. So this is my first policy. This is my second policy. This is my third policy, like number A here. The first policy, second policy. Number A is the pass checks. This is something we're going to add later. Number B is the code reviews. That's what I'm enforcing here through require approvals. And I'm saying that don't even bypass me. So create the branch protection rules to provide the authentication, two-factor authentication. Done, and that's it. Now it's just a matter of testing. So same branch, the main branch, making one more change. See the change? I can see the change here, Git diff as well. Yeah, it's been modified. This is the actual modification. Now let me try and commit. So you can see it's gone into the commit history. The head has moved to this commit. Now is the interesting stuff. So the main branch is what it shows. That's what I'm on. Remember last time it allowed me to push the changes. I'm going to try and do the same. Git push origin, username token. Doesn't. This is where my protection rule comes in. So it says protected branch, you can't merge and you have to raise only the pull request. And to do that, what that means is I need to create a branch as well. So what do I need to do here really is I'll have to go back in terms of commit as well, because I can't merge or make changes to the main, right? So I have to do this via branch. So how do I revert the changes is where I'm going to use git reset. And not only do I want to revert the changes, if I want to remove them from even my working tree, because when I revert the change using a soft, you can do this, git reset and head -1, right? This will remove it from the commit history, but keep the changes locally. I can do that as well. If I use hard, it will be removed from my working tree. Let's say I want to keep it in the working tree. I'll just say reset. So it is gone back from the commit history. Commit head has moved back one commit back. You can also be very specific to the commit. It will go to that one now, right? So that's what happened. But the changes are there because I just did a soft reset, so that whatever changes I made are in the working tree, not even the index. It's in the working tree. That is good. So I can do this git checkout -b, create a new branch, feature y, git add. I'm switched to the branch, remember. And now if I do git add or just git commit, or 03, now you see okay, it's gone into this branch. Now it's committed to this branch, and now what I can do is push the changes not to the main but to the feature branch. Good. So new branch created. You can see that here. This is 82, and my feature branch should have moved to one commit ahead, so 83. You can see that. Right, it has that change. In the feature branch, I have this change, ch03. In the main branch, I do not. And now I will do the same thing, raise the pull request, but you'll see some difference now. Creating a pull request, see what happens. Earlier, it gave me an option to merge. Now, this is where you can implement certain policies. I believe I've already added the okay. So what has happened is what I forgot was I raised a pull request against the upstream. So it has taken me to the upstream. What I should have done instead is used my own repository. Yeah. Now between this and this is where I have this change. That's where I'm raising a pull request between my branches of the same repository. And now you do see the change. It says merging is blocked. Why? Because you need to go through the code review first. right? At least one review approving this request has to be there. If you have an integration with CI, this is even better because then you have actual CI check as well. So you'll have two checks here, two policies waiting, and it will be blocked until those pass. The statistics has to pass, and that means CI has to pass, and it will also give you the basically it will show you the in the commit history itself. You'll see whether the CI checks have passed or not. If I have a repository where I have run this, maybe I can show you from earlier. Not here, but here's a lot of repositories. You're gonna find the status checks passing, or the status of what happened during those checks, basically. Yeah, you can see it here. So this tick mark just tells me that the status check for this has passed, meaning this has come from the Jenkins. This is how you will see it, right? And based on that, your pull request, whether they were allowed to merge or not, is determined here. This one failed, this one passed, this one passed, right? So it will show up in the commit history itself once you have that two-way integration between Jenkins and Git. That is what we're gonna do next week. Now, since I don't have that, I'm not gonna get into the status check. I'll show you later next week, but right now I can demonstrate the code review here. To make this possible, I need to have a reviewer first. That is the reason why I have created the secondary account. So you can do that. You can create a secondary account, or you can ask someone to review, your friend or your partner. You can pair up with someone and have them review. So this is my user ID, for example. This is my reviewer account. So what do? I add the reviewer as the collaborator on this project first. To do that, you'll have to go back to this repository settings, and from there you add collaborator and teams, and this is where I add the collaborator with their user ID on GitHub. Now, when you do this, you will not see these options. There is something special or weird about my account, so I get these options, but you will typically have people with the collaborative write access by default. So if you don't see this, it's fine. If you're do this as part of a lab guide or something, you will definitely not have that option anyway. So if you don't see it, that's fine. Just add the collaborator. When the collaborator is added, they send a request invitation. Generally, they will get an email with this as well. Now, I'm not going to go into my email and look at it. I may see a notification right here as well, or I will definitely get an email for it, right? So I can go to, as a reviewer, I go into my email, and from there, I can get a request, or I may get a notification. If I go to notification, you can do it from here as well. You do get it somewhere in the notification section. So it may be there, but even if you don't, you can look at the email and click on this to accept the invitation. As a reviewer, I'm accepting the invitation. Now I have access to this, and I can go to the pull request and add my review if I'm requested for a review. So how would I do that? As the original account, I'm the author of this change, and what I say is, oh, I'm raising a pull request. I want this to be approved, and there I add the reviewers. Now I can add a reviewer. I see them because they have approved. I can add them as a reviewer, and now once the reviewer has been added, this is waiting. It's still pending for review, right? I'll switch back to the reviewer account. This is a reviewer account. I go here to the pull request. Again, I would get an email. And now when I go here, I can see that I've been requested with a review. You can see the changes. I can click on add your review, and I can see the changes here. If I see a problem, I can ask for changes. So I can approve, I can request for the changes, or I can just add a comment. In this case, I'm going to say approve. And if I approve, the moment I approve it, you are going to see the status here changing. And now I am able to approve. Merge the changes in. So the changes can only be brought in via the branches. That's the first policy. Okay, and once the changes are in, I can also delete, I can revert the changes, I can delete the branches, I can do all of that from here. So this is the beginning of our branching policies enforcement, let's say trunk-based development model, and where we lock down the this branch, the main branch, that is a trunk. We allow changes only via pull request. We have a policy where we say that this has to be reviewed by at least one reviewer, and this should pass the CI checks is what we will add later once we have the CI. And once we have this configured, the next thing that we will just have to configure is a release branch. So you have a release branch, and then you have brought it, whatever needs to go to the release at the end of the release cycle, let's say after 15 days, you just merge it here, again raising a pull request, may have multiple other checks here, and then whatever goes in here, you may want to just deploy to your environment, maybe a production environment. That's as simple as setting up a very simplistic, very efficient workflow using a trunk-based development model. Any questions so far? All right. The only one thing that I'm going to talk about next is about how do we cut the release. So release as in you tag, and a lot of times you'll see the versions available with an application or a repository, right? Let me see if I can show an example. So I have some application here. It has a few releases. What does it mean? And at that time, it's like a snapshot of that code at that point of time available as an archive, published here as a release. Now, how did this happen is you just have to tag it, and then you publish those tags to the repository to here, right? So how do you go about tagging is what I will just show you very briefly here. So let's say I want to create I will switch to main, bringing all the changes from main, right? And then I will create a branch, a new branch like release 0.1. At the beginning of the sprint, I've created this branch, let's say. You can do it from main branch also, no problems there. So it's nothing like that. And I can tag it using git tag, and you can have a tag, simple tag like this, or you can have a tag like annotated tag with more information about it. So git tag, and I can be more specific, like this is a more like a semantic versioning scheme where I'm saying that this is the major version, this is the minor version, and this is the patch version. And then I will say, hey, release. So if I see git tag, I'll show you the difference with between both these tags, right? So git show 4.2, git show version, yeah, this is the annotated one with the tag and then the commit details and so on that I tagged it out of. So at this commit, I tagged this, created this tag basically. In this case, I just have the commit details, like whatever the last was, and that's it. Here I have a proper, annotation about what happened, why did I create it, maybe anything specific like change logs and whatnot. Can add that here. You can also delete the tags, and you can publish the tags too. So deleting the tag is like that 4.0 we want to delete, and I can push the tag. So tag is local right now. It doesn't get reflected here yet. You don't see any releases yet. So to create these releases or cut the releases as we used to call it, I would push the tags. So git push origin, and the tag ID. All right, so the new tag has been created and I have a release here. That's how you create the release. It's as simple as that. And if I download it, I basically get a copy of that code at that point in time. That's my kind of releases here. So I see the tags here in the releases section, basically. Right, so that's how you go about it, basically. So that's about Gitofy as the mission. And as part of this week, what we have learned is how do we set up the Git-based workflows. And an example of that is a trunk-based development model. So we talked about what are branching models, how do we set up the policies to enforce those models. In this case, it's a trunk-based development model. Alternative to this are something like GitFlow. There is a variation of it called as GitHub Flow, and there are a few other alternatives to it. But trunk-based development is emerging as a very popular, simple option that you want to implement. And it's very simple to implement. Once you understand trunk-based development, you can implement anything. In this case, we just have to protect develop branch, have certain policies for it, release branch, and a master branch. So you will have 3 different branches here. We will have this policy for 1 or 2 branches, basically. That is the difference. And once you understand how to implement one, you can enforce anything else as well. Now that's about this week's session, and that's about this week's mission. That is about Gitofy. Any questions? You can put it in the Q&A section. You can put it in the chat as well. There's a question from Sai Durgesh. What responsibilities does a DevOps engineer have in managing real-time operations for Git? Now, depends on the organization and the role. Sometimes you are responsible for cutting the releases. So sometimes you are responsible for, you're the admin, right? So you are an admin for the repository as well. You are responsible for setting up these branching policies. You are many times you are responsible for even maintaining the branches and so on. Definitely you're responsible for a lot of times release engineering, like how do we take this and publish it to the production and so on. And from that point of view, a newer technology that is GitOps is also based on these kind of workflows. So if you understand these workflows, you can implement GitOps very well. GitOps is about how to set up continuous deployment for Kubernetes using Git-based workflows. That's why this is important. This code reviews, this policies, this branching, merging, pull request-based workflows. These are the things you definitely need to understand in order to use tools like Argo CD or Flux to set up continuous deployment on Kubernetes as well. So as a DevOps engineer, you definitely need to know about these Git-based workflows, and you should be familiar with these, and you may have input and say in deciding the workflows and modifying it and porting from one system to another, one platform to another, one Git hosting system to another. Those could be your responsibilities as well. All right. That's it. I'm not getting into merge conflict and everything. So we'll probably take it up as one of the calls that we do during the Thursday sessions. Can pull requests be created from the CLI? Could be a possibility. Everything that you can do here, possibly you can automate it. So I've not seen an example of it, but I don't see that it being completely impossible as well. So it should be doable programmatically. What is GitHub in action? It's more about GitHub Actions, not GitHub in action. GitHub Actions is more like an alternative to Jenkins as a CI platform. And with GitHub Actions, basically whatever you want to do with CI, like build, test, package jobs, you can do that with Actions. You can see the tab here, GitHub Actions, right? And this is like you can add a pipeline kind of jobs, you can sequence them, and basically whatever your Jenkins can do, you can possibly port at least a lot of those jobs, you can possibly port it with to GitHub Actions. So everything runs out of Git. You don't need a separate platform for it. It is well integrated with Git, and you'll add some code into your GitHub repository, just like a Jenkins file that we will look at next week. You can add some code into the Git repository, and whenever there's a change here, it will trigger this sequence of steps, run your tests, builds, whatever it is, packaging of container images and whatnot, and basically it's a replacement for Jenkins as a CI platform. That's what GitHub Actions are. All right. Fine, folks. So if there are no further questions, we will be closing the session here. And again, we are on mission number 3 here. I would be updating the mission. Those of you who are members, you will already have access to it by tomorrow or so. If you are not a member, I highly recommend you get the membership. We have also launched the yearly memberships, which you can avail from the site directly. So if you go to schoolofdevops.com, we have a membership page, pricing page. You can start from there. And if you are a member, you will log into the DMS dashboard. That is the DevOps mastery system that we have. And the dashboard is your visualization to everything to get started with, like right from roadmaps to courses, challenges, community. And this challenge is what we have codified here. So you can see that, oh, if once I complete, this opens up for me, I get a badge as well. For example, I've completed this particular one. I have a badge called as containerize. This badge will show up on my profile at some point of time. And this is something I've completed. And the Gitofy is the next mission for me. And if you are a member, if you want to know how to get started with the next part, basically just follow this challenge. Every week, we are releasing one new challenge. And once that is available, you go and complete those tasks. Those tasks could be going through a course, completing a project, completing a quiz, and that's what it is. And next week, we're going to come back for the next mission. That is going to be pipeline it. A very interesting mission. We will be talking about how to set up continuous integration using the modern technologies. Jenkins with Blue Ocean UI, Jenkins file, that is a pipeline as a code, multi-branch pipelines. Very, very interesting topic that's going to be next week. So don't miss that session. And with that, we will close it for today. Thank you. Have a wonderful week ahead. And, I look forward to see you next week. And I look forward to have you complete all these missions as we go along. So thank you. And we'll sign off here. Bye-bye.